Again, all of this is review, so it should be familiar to you. So let's start by talking about the distributive property. What would you say is one problem that many students come across with the distributive property? Like, what's an error a lot of people make?
They don't distribute all the numbers inside the parentheses.
They don't distribute to all the terms inside the parentheses. You normally distribute to the first one, and then sometimes you forget either the second one, and sometimes we might have 3 or 4, and you forget those as well. So it's really important that you distribute to all of the terms. So for instance, if I give you A times B plus C, we're distributing the A to the B and to the C, right? Now, you'll notice I have 3 different variables, so I want to make sure that when I write them in alphabetical order. So A times B would be AB, and A times C would be AC. So if I distribute, I would have AB and AC. Okay. Can I distribute the A here? Yeah. Just because it's at the end of the parentheses doesn't mean you don't distribute the exact same way. Another misconception, okay? So you want to make sure that you still distribute to both terms. It's okay if it's at the end. And again, it's alphabetical order, so A, B, and in this case, it's minus AC. Biggest thing, though, is make sure you distribute to both terms. Or all terms. So if there's 5 terms, you distribute to all of them. Okay. I'm going to give you 6 examples that I would like you to try. If you need to use your group, that's fine. If you can do it by yourself and then check with your group, that's okay too. But again, this should be review. So again, you want to make sure you're distributing to all the terms. So this first one should give you 2x plus 10. This one, the 8's at the end, but that's okay. We're going to just distribute. And I get 8 plus 16x. Now, when we're really doing any problem, we should always have our answers in what we're going to call standard form. Standard form is when we have our variables first and then our constants at the end. So for this particular one, we need to flip it and do 16x plus 8. Okay, so if you didn't do that now or originally, go ahead and do that now. But our variables should come first and then our constants. If we have more than one variable, it's going to go in alphabetical order. And then if we have a variable with a larger exponent, the high exponent goes first, and then we go down to the constant term. Okay? Number 3, if I distribute, I get negative 3x minus 12. Number 4, who can tell me what x times x is?
X squared.
X squared, nice. X squared. X times x is x squared. And then I have a minus 4x. So do you see how I have my highest exponent first and then my constant term, and then my single variable exponent? Okay. All right, when I distribute y, I get y minus x squared. Do we like how that's written? No, what should I do?
Put the exponent first.
Put the highest exponent first, so I'm going to rewrite this as negative y squared plus y. So highest exponent to lowest exponent are constant. Yes?
Does it matter if it has to be like an exponent, or can you do like 2y?
It has to be an exponent. So when you're multiplying y times y, you'll get y squared. If you're adding y and y, that's when you get 2y. So when you multiply or divide, the exponents will change. When you add and subtract, just the coefficients in front change. Okay? And then lastly, I'm distributing in a negative. So I get negative 6 plus 3x. Do I like how that's written? No. So I'm going to switch this one as well and do 3x minus 6. It's just a habit that we want to get into because as we move forward into this semester and really a lot in second semester, we want everything in standard form. So if we get into that habit now, it makes it easier. Are we okay with combining like terms? We remember that from IM1? I'm sorry, distributive property? Okay. What about combining like terms? Who can tell me what a like term is? Yes, ma'am.
It's either two numbers that are, it can be the same sign or different signs, or it's two numbers with variables or just variables.
Okay, so give me an example of something that's a like term that has a variable.
Like one, would be like 2x and 4x.
Okay, so it has the same variable. Does everyone agree with that? Okay, so a like term has to have the same variable. That's super important. So you can't combine 4x and 3y. Those don't combine. So it has to have the same variable. There's one other thing that it has to have that you may or may not realize. Yeah?
It has to be either a variable or a coefficient.
The coefficient doesn't have to be the same. So you could have like 2x and 5x, right, where the coefficient's different, but there is a number that has to be the same. Any ideas what that number might be?
The whole number? I forgot what it's called. The X.
It's going to be your exponent. So your exponent has to be the same. Whoops. That should say same exponent. So it's going to be the same variable and the same exponent. So for instance, if I gave you x squared plus x, am I allowed to combine those? No. They have the same variable. They both have x's, but because their exponents are different, we are not allowed to combine them together. Okay? Does that make sense? Awesome. So let's try a couple combining like terms. And again, when we're adding and subtracting or combining like terms, you are just changing the coefficient. The exponent does not change. The only time the exponent changes is when you multiply or divide. So here's 5 problems. I want to see if you can combine like terms. So for it to be a like term, one more time, it has to have the same variable and the same exponent. Okay, do not change the exponent. Make sure that if you have exponents, it's the highest exponent to constant. And if you have more than one variable, it's in alphabetical order. Okay, those are going to be some things you want to look for. What are my like terms in number 1? All of them. So 14 minus 19 gives you negative 5. Negative 5 minus 7 is negative 12D. Okay? Number 2. Number 2, what are my like terms? 5x squared and x squared. And that one should come first, right? So 5 plus 1 is 6x squared. And then this negative 16x, I'm just going to rewrite. So the 5 plus the 1 gives me 6x squared, because remember, you don't change the exponent. And then the negative 16x just attaches at the end. What are my like terms for number 3?
Oh, wait, no, it's an 8.
The negative 7b and the 4b. Which term should come first, though? The a, alphabetical order. So I'm going to rewrite the 2a. And then negative 7 plus 4 is negative 3b. So again, if you have them backwards, just go back and fix them. We want to just get in the habit of writing them in alphabetical order and in standard form. Okay. My like terms on number 4 are my h's and my g's. If circling or underlining helps you figure out what your like terms are, then feel free to do that. What comes first, G or H?
H.
G.
G. You have to go through your alphabet. Okay, so G comes first. 10 plus 2 gives me 12G. Negative 14 minus 9 gives you what? Negative 23H. Good. And then for the last one, I have XY and XY, and then I have WZ and WZ. What happens here? They cancel. Negative 8 plus 8 is 0, so I don't need to write that. 10 minus 2 is 8WZ. How do we do on that? Good? Okay.